Welcome. This is the Advanced Cooling Facilities Incubation Team introduction. Myself, I'm one of the co-leads with Don Mitchell, and we will be talking about what this team does, what we're trying to achieve, why we were formed, and what we hope to produce as products going forward. Don is, looks like Don is here, but muted. So we are a subgroup dealing with the connection of liquid cooling systems to data centers. And
Hey, John.
sorry, my screen went away there for a moment.
John, can you hear me?
Yes. Hey, Don.
Well, it's good that these internet things don't pick up the cursing. Hopefully they didn't. As I've been going through, for some reason, it seems to be a cloud over me, and I may fade in and out. I heard you introducing here, and I appreciate very much. Maybe picking up where you were, we're integrating. The Advanced Cooling Solutions team has been around since, I believe, 2017. They've been introducing cold plate and liquid to the chip or immersion and rear door heat exchangers. The DCF team is also showed up around then. And we were brought in to harmonize the process of integrating the liquid into data centers. And am I coming through okay, John?
Yes.
Okay. So if you maybe move on down to the, so we're looking at here. One of the key things we find in the wonderful world of liquids, we had this conversation, is we're not paving new ground. Liquids have been successfully deployed in data centers for years. The phenomenon we're working with is the data center of today, more than in the past, is being built on a slab floor, and people are building it for air cooling, and they're looking at adding liquid in the future. And that's a different consideration than starting from day one. We still have to deal with the concerns of people about liquids in general. Liquid cooling has been a very reliable solution for data centers for decades, but decades of reliability are marred by one or two events that cause people to think it can be unreliable. So we need to marry the successes of the past with a method of deployment and planning for facilities to add in the future. And that's an area that really hasn't been mapped out very well, but there's technologies in the world that are making this easier and easier. The slide that John has shown right here kind of shows our area of focus. We're not trying to take over the issue of distributing proprietary liquids through racks through a CDU. That's being addressed by the ACS team. What we're looking at is how they connect, how you would add them to a facility, how you connect them either to primarily the facility water solution. So if you have a data center in existence and it already has a chiller loop, what plans do you need to make in order to add a cold plate or add rear door heat exchangers or add immersion in a couple of years from now? And a couple simple planning steps can make that a lot easier. It also can make it more reliable and also improve your overall efficiency and performance. And that's what we're looking at. There's several different levels of this we're looking at. One is the concept of connecting to an existing loop. Another concept could be, would you, for some of these solutions, they operate at higher temperatures. Would you want to connect to the loop, or would you want to connect to the return side? Would you want to use the higher temperature return liquid to, for example, cool a cold plate solution or immersion solution which arguably can be successful with 45 degrees centigrade water, well above the temperatures that are generally required for chill water and air-based solutions. And then the other question ends up being, would you even want to connect to the existing loop at all? Would you want to create a new loop, especially if your primary focus is going to be, say, cold plate or immersion cooling? Would it be more efficient, effective to put in an elevated temperature loop and not go through the issue of connecting to, say, a chill water line? Or in some cases, there are data centers that are evaporative cooled right now, and they have a very successful model for evaporative air cooling. And they may just want to put in provisions to add a pipe and a pump and a heat exchanger. And actually, if you think a little bit further down the path, that heat exchanger, if you're operating at elevated temperature, could easily be or maybe efficiently be used for energy reuse and heat reuse. As we are a global organization, the interest in the heat reuse and energy reuse is already happening in Northern Europe. It is probably going to be happening in the next couple of years in the United States more, but Europe has a leadership role in here, and so does China. So we're trying to kind of knit all those things together. Moving down the next slide here real quick. So this actually kind of captures what we're talking about in some pictures. And what we have here on the side is a reference design, kind of looking at the concept of one method of connecting to an existing cooling loop would be to add CDUs, coolant distribution units. What you're seeing is two of them, and you're seeing two of everything because in many data centers, the concept of concurrent maintainability and redundancy end up being of interest. What you're also seeing in the picture is the concept of immersion cooling coexisting next to racks, and those racks could be rear door heat exchangers, or in many cases, they could also be a rack-based cold plate, or there's also rack-based immersion cooling. And one of those racks might, you could either have drops directly to each one of those, or you may have a CDU down at the end. So the concept here, and we're still at the socialization level, and what you're seeing in the middle is this little chart that was started to compile and trying to give an estimation of what are the parameters that need to be defined or simplified. There's a certain amount of, there's a strong relationship between, for example, the amount of heat that you can carry out through a pipe versus its flow rate. And there's limitations on the maximum flow rate you can have. Can we boil these down into a simple set of guidelines and tools to make it so an owner doesn't have to fully design and deploy pipes at day one, but they could have provisions made so that sometime in the future, they could be deploying the pipes and the infrastructure associated with their next generation cooling solutions. Kind of moving on through a little bit more. The next slide here, and Jessica, are you online?
Yes, I am.
So
Good
Jessica,
morning, Don.
Good morning, and apologies for my ability, my last minute problems with Zoom, but I'm glad to see you don't seem to be having those problems. And you explained your role a little bit and what your perspectives were from the previous couple days.
Sure, thank you. So my role, I'm co-chairing the incubation committee. So that's where I'm active, as well as I'm very active within the advanced cooling solutions. I used to lead the cold plate work stream before I joined the incubation committee. So we have talked about this harmonization and the importance of it for quite some time, really from when we introduced the advanced cooling solutions, of highlighting that the ACS, we're focusing on the secondary loop or the technology cooling system, as Don was showing here in the earlier slide. And really, the last couple of days here, we had a really great session on full day, really, on November 10th, talking about bringing in different perspectives from the industry of what is important, what is it that we should be focusing on going forward, what are kind of pain points as well when it comes to liquid cooling for users today. And some of those things that we discussed here is really one of the main priorities, talking to users of liquid cooling, or also if we're saying future users of liquid cooling. Everyone knows that liquid cooling is coming. I mean, if it's not already here, right? It's definitely coming. And there's some priorities for liquid cooling users when it comes to just this harmonization as well. So I would like to just speak a little bit about that here. And it's really of having, one thing that came up during these discussions was to make sure that you have those interfaces between the TCS loop and the facility water system loop defined. So having defined interfaces between where you basically know that one system is ending and the other one begins. What do those interfaces look like? As well as the interchangeability. That was something that was brought up as well, of not having to deal necessarily with the proprietary connections and interfaces, but that it's something, one interface that is common, that can be used. It doesn't really matter which manufacturer that you're, or supplier that you're buying from, but the interchangeability was a big one. So those are a couple of points from the beginning. I don't know, Dawn, do you want to have a discussion around those, and I can move on to a few other observations, or how do you want to?
Yeah, and so one thing I will say, we're learning a lot. It seems like one thing we are learning is that everybody looks at data centers just a little bit differently. And especially when you look at it through the eyes of someone whose focus is immersion cooling versus someone whose focus is cold plate, and someone whose focus is door heat exchangers, for example, and also those that are focus is just the typical hot aisle containment solution. We've been meeting on a weekly basis for since August, which isn't that long a time. We are starting to make progress, but these discussions that Jessica brought up on standardization, some solutions, for example, one of the most current discussions we have going on is who uses coolant distribution units. Do you actually need a heat exchanger, or can you connect directly to your existing chill water loop? And there's pros and cons on that, and we're going to be having a discussion next week on that. The suggestions to prevent cross connection, for example. In all honesty, I had not really considered that to be a major problem until all of a sudden it was brought up as being, this past week, as being something that people are have the potential of doing. It was not something that hit me as hard as some. The leak detection. Go ahead.
Yep, totally agree. That was the next observation that I was, just as you were saying, that I made from the ACS meetings, right? Of how to prevent cross connection. And the suggestion from the community, right? Color coding, that would be a minimum requirement to making sure that you're not cross connecting hot to cold, or doing different connectors for inlet and outlet, and standardize those connection types as well. So just wanted to add that on.
Well, yeah. And so to a certain extent, some of the questions that we have are, there are some applications and that are being looked at from the rack level that maybe are not as essential at the facilities level. I could see the potential of misconnecting a supplier return to a server easier than I could see somehow screwing up your supply and return of your big pipes going through your data center. But the concept, as we get closer and closer to the IT function, is something that deserves attention, and we'll be looking at that a little bit more after this week's discussion. Another area. Go ahead.
And harmonization as well, right? Between that of saying, okay, whatever that we're coming up with as well within the ACS, right? Making sure that the ACS and the ACF are harmonized with the approach that we're taking, right? How can we make, how can we make it easier for the user in the end, that they don't have to keep track of several different standards or several different methodologies per se, right? But how can we make that part easier? And then the big discussion that, of course, that always comes up with liquid cooling is really the leak detection, mitigation, and intervention. And that was another one that, of course, I mean, it's a it's a topic that is being brought up quite frequently, and of course, people are nervous about liquid in general and close to any type of IT equipment. So I think that there needs to also be a little bit more education around, really from a TCS and from a facility side of there's a lot of differences and similarities there. There's a lot of things that we can use, and depending upon what really the customer or end user want to do when it comes to what level of leak detection, for example, that they want to get to, there's of course, you can't separate just the secondary loop per se, or the TCS loop out of it, of saying we're only going to do leak detection here and not the rest of the data center, right? So there will be a lot of crossover. Where does one stop? Where does the other one take over? And what are potential requirements as well of having just liquid cooling within the data center, right? And how does then that connect to the TCS loop as well?
That's a great discussion. In fact, it deserves a lot of attention. I know that the ACS teams have started authorship of a leak detection and protection white paper, and we're taking a look at it. And one of the key questions ends up being, and one of the areas that we've been looking at with the Advanced Cooling Facilities team, is the trade-off between risk and benefit. And so a solid piece of pipe, you don't necessarily need to put, another pipe around it or put a drip tray under it if you don't have condensation issues. And so that's the issue. More issues with pipe happen with condensation than leakage. And what I mean by that is, I think most people perceive the concern on the larger pipe that isn't being disconnected on a regular basis. The primary concerns that we've had over history haven't been the pipes leaking as much as a condensation effect that appears like leakage. And so some people, if you're working with pipe that is above dew point and you don't have condensation, do you need to put leak collection underneath a perfectly solid piece of pipe? And then when you go short of perfectly solid, at what point do you need to put collection trays, or do you just need to put detection? The collection trays, if you're adding them at year 3, can be a big challenge and can pose all kinds of questions. Do you really need that challenge? Are you really? And this is not, it may sound like you can put this in opinion. We're trying to put it into science. And when I say science, we've taken a look at the concepts of MTBF in terms of mean time between failure. Are there components that are so reliable that you don't need to protect them because your risk factor, in all honesty, is maybe a slight drip? And then the other aspect is looking at what we call failure mode, effects and analysis, where you actually will go through and say, okay, what is the worst case thing that could happen at this point? And if it's just a drip, maybe you don't need to put a 4-foot wide, 30-foot long drip collection tray. on the chance that you might get 1 or 2 drips. Maybe just having a leak detector rope would be all you need, and as long as it's not hanging over the racks. It's a slightly different philosophy than what goes on inside the rack, and so we need to look at the recommendations of the ACS team on how they're approaching leakage and protection, which is a different statement. When you have a cold plate and you have a bunch of servers stacked up and they all have connectors, there's always the probability of those connectors leaking is different. So this is one of the work products that we're going through, and back to the harmonization concept. What we're finding is it's not an easy path, but we are seeing potential in that chart that we showed earlier. We're seeing some potential of giving guidance that doesn't compete with the architect or the engineer, but allows owners of data centers to make some plans at day 1 so that they can be successful at year 3. And to a large extent, the interest we've had attendance from both leased space data centers, also known as colo and MTDCs, and they are very interested because they are building a hotel and their tenants may change. But we've also had participation interest from the cloud providers, and that are they don't know exactly what footprint. In some cases, they have a better idea, but they're seeing the emergence of liquid cooled applications coming rapidly but unpredictably. And so where you're going to want to add those is going to be a question, how to design to add them. There will be some that may go to entire data centers that are liquid cooled. That is not our focus, because those people will start at day 1 with a liquid cooled footprint. We're looking at trying to help people that are starting with a air cooled or a traditional data center philosophy, and make it possible for them to add liquid as those applications grow. Let's go to the last slide real quick, because I think we're almost toward the end of our time. So our calls to action here. We have a weekly call discussing these topics, and we're collecting the information there. We're looking at contribution, and we're developing reference designs and insights and guidance. And we're also looking at how are there places where an OCP ready standards, if there's something we could tell people this should be done, does that serve a purpose? It says PDU, it meant CDU. As a typo on my part. The issue of coolant distribution it's a different philosophy we're finding if you talk to rear door heat exchangers versus cold plate versus immersion. Can we find a harmonization that lines up with all 3, or at least a matrix of if a data center owner sees in the future that they're going to add any of those 3, they may want to have set up for one place. If they decide that their only future is going to be say cold plate or immersion, they may want to take a different approach. And as you also see on this page, we have some URL links that all tie in back to the wonderful OCP webpage. But there's a calendar for when we have our meetings, which right now are Tuesdays at 8 o'clock West Coast, 11 o'clock Eastern, and 1600 over in GMT land. We have a project wiki, and there's a mailing list, and we would definitely like to have people participate in the mailing list. Even if you're not participating in the call, you'll get our weekly updates and kind of see where we're heading. And we do we go around and tap the industry for some of the industry leaders to speak at some of these events to make sure that we're heading on the right direction. Got like 3 or 4 minutes left. Are there any other comments that people would like to share?
Hey, Don, we actually did have a question come up in the comments section.
Oh, super.
The question was, does insulation around the pipe reduce or eliminate condensation? Great
question. And short answer is it can if you do it right. But there's also a phrase in the industry, CUI, which is corrosion under insulation. And that's what happens when you violate your vapor boundary. So to the point that is being raised, insulation can definitely is used whenever you have pipe solutions that are operating below dew point or potentially below dew point. And they have been used very successfully, but they do require a lot of attention. It may be a challenge that a data center owner may want to avoid. And so you are finding some cooling solutions that deliberately set themselves up to operate above dew point. And that's getting more and more feasible, even the air-cooled environments. You're seeing schema in that matter. Any other, Jessica, do you have any insights on that? Are you finding a condensation issue with your solutions?
Well, I mean, you're dealing with it in a maybe just a slightly different way, right? So depending upon if you use CDU or not CDU, but making sure that you're just keeping the temperature above the condensation level, right?
Yeah.
Of mitigating it in that way. Yep.
And I'd add, I'm sorry if I may, I'll add that the question was, can it prevent or minimize, I guess, condensation on the pipes? And the answer is, it really depends on how well it's done and the materials used and the thicknesses used. So if it's well sealed and there aren't a lot of exposed areas and the insulation is thick enough for the temperature range that the pipes are going to see with respect to the dew point, then yeah, you can completely eliminate with being very good about sealing around valves and joints. You can eliminate condensation entirely.
Exactly. So it's something that should be respected but not feared. However, as Jessica was highlighting, if you're working with the cold plate and immersion, generally speaking, those can operate at temperatures well above any dew point that you would see in a data center. Mm-hmm. But it's something that it can vary a lot by region too. Some regions have greater humidity in the air and their dew point is a lot higher. Some regions are low humidity and dew point's a lot lower, and it's not a risk factor for them. But it's a great question.
Hey Don, if I could chime in one other thing, a lot of times when we talk about insulation and whether or not it's appropriate, it's needed, et cetera, we focus on the steady state operation. And a lot of times the issues that we run into with condensation are either during startup of the ITE, when we don't have that heat buildup in the facility yet, and in the loops. That's a situation when you can have temperatures not cooperating well with your dew point. And then other scenarios where what happens if somebody blocks the doors open, you're doing a big ITE refresh. I mean, it's happened before. There's well documented cases. And so a lot of times when we talk about these things, we think that the design condition is the condition under which the ITE is going to be operating throughout the course of its life, when nobody's there and everything is normal. When in reality, the design condition is startup and shutdown of the ITE. It's tech refreshes where somebody's blocked the doors open. All these different scenarios have to be taken into account when you're trying to evaluate whether or not something like insulation is necessary or prudent.
Well, that's a great lead in, and I guess it also leads into John Gross. You're the next speaker, correct?
I am.
He is. John, I'm going to go ahead and stop sharing my screen and pass that to you. While John gets set up, everyone, there was another question that came in. It was, do I have to be an OCP member to join these calls and listen in? The answer is no. You do not have to be an OCP member to join the calls and participate either in the calls or in the mailing list. We welcome folks just to join and get involved. John, the share screen button is down there at the bottom. It should be in green.
Yeah, I'm getting that squared away right now. Okay, can you see my see the slide pack there?
We can.
Okay, great. I'm gonna move it over to the other screen here real quick. So give me just a second. Sorry about that. Let's try. Okay, what are you guys seeing right now?
We see the controls for the presentation.
Okay,
Not full screen.
okay, it keeps bouncing back over to the wrong screen on my computer. Hold on.
If you do it again though, there's a display setting up on that. If you go back to share full screen.
Back to slideshow there, John.
Okay, hold on.
The car looks cool though.
Yeah, it's not so much the issue of the Zoom throwing it on the wrong screen. It's PowerPoint is throwing it on the wrong screen. So relative to my camera, but that's okay. Well, you guys should be looking at the slide pack, not my my camera anyway. Okay, can you see the slide pack?
We are viewing your desktop now.
Okay.
The John Gross Corvette.